So what could a simple coin flip and the number 7 possibly have in common? I mean, at first glance, absolutely nothing, right? One is all about randomness, total chance. The other, well, it's a symbol of something totally certain. Today we're going to dive into these two super powerful, kind of opposite ideas in math, probability and prime numbers.
Yeah, it's a question we ask ourselves all the time. Am I feeling lucky today? Maybe you're hoping to just nail that perfect parking spot, or I don't know, find a 20 on the street. But what if I told you luck isn't just some vague feeling? What if it's something we can actually measure?
Yeah, that's right. Believe it or not, there's a science to this stuff. Behind every single thing that seems random, rolling dice, a weather forecast, there's actually a hidden mathematical structure. So let's pull back the curtain on all this chance and turn that gut feeling of luck into something we can actually work with.
And that tool, the one we use to measure luck, it's called probability. You can think of it as the language of chance. It's what lets us put a real number on something that feels uncertain. It helps us answer that one big question: what are the odds?
Okay, so how do we actually do that? How do we get from just a random guess to a real, solid calculation? Well, it's actually way more straightforward than you might think. Let's just break it down.
Really, it all just boils down to 3 super simple steps. First, you just count up the number of ways you can win. That's what we call the desired outcomes. Second, you count up all the possible things that could happen, whether you win or lose. And finally, you just divide the first number by the second, the wins by the total. That's it. When you get right down to it, probability is really just a simple fraction. All right, let's take the classic example, right? A coin toss. Let's say you want it to land on heads. Okay, that's one desired outcome. Now, how many things could happen? Well, just 2, heads or tails. So you take 1, you divide it by 2, and you get a 1 in 2 chance. 50%. See, it really is that simple.
Okay, let's try this with something else. How about a standard 6-sided die? What are the odds of rolling a 6? Well, there's only one 6 on there, so that's one desired outcome. And there are 6 possible faces in total. So 1 divided by 6. That's about a 17% chance. Yeah, not the best odds. But wait, what if we change the question a little? What are the odds of rolling an even number? Now our wins are rolling a 2, a 4, or a 6. That's 3 different possibilities. So 3 divided by 6, well, that's 1/2. 50%. How about that? Exactly the same odds as a coin toss.
And this same basic idea scales up to things that seem way more complex, like a full 52-card deck. I mean, what are your chances of drawing one very specific card, like the Ace of Spades? It's just 1 in 52, pretty slim. But what about your chances of drawing any ace? Well, there are 4 of them, right? So now your odds are 4 times better, which is about 8%. Or what if you just want to draw any heart? There are 13 hearts in the deck, so that's 13 chances out of 52, which, if you do the math, is exactly 1 in 4, a 25% chance. This isn't just a game, by the way. This is literally how pro card players and casinos are constantly calculating the odds to make their big decisions. Okay, so far we've been wading through this kind of messy, unpredictable world of chance. But here's the thing. Math isn't just about trying to manage uncertainty. It's also about finding the complete opposite. I'm talking about absolute, ironclad rules that are basically the foundation of, well, everything. So let's make a big shift here. We're going to go from the random to the fundamental. See, hidden inside our entire number system, there are these really special numbers, and they act like the fundamental building blocks for all the other numbers. They're not random in the slightest. In fact, they follow this very strict, almost secret rule. Here's the basic idea. Just think about the number 6. You can build it by multiplying smaller numbers together, right? 2 times 3. It's made of parts. But now, look at the number 7. You can't do that. You can't break it down into smaller whole number ingredients. The only way to make 7 is by multiplying 1 times 7. It's not built from parts. It is one of the parts. It's a building block. And these fundamental, indivisible building blocks of the number world, well, they have a special name. It's time for us to meet the prime numbers. So here's the official definition, if you want to get technical. A prime number is any whole number greater than 1 that you can't get by multiplying 2 smaller whole numbers. Think of them as the indivisible bedrock of our entire number system. They're totally solid and totally certain. So here are the first few of these mathematical atoms. You've got 2, 3, 5, 7, 11, and the list goes on and on. But what's truly mind-blowing is that every other whole number, literally every single one, can be built by multiplying these primes together. So a number like 12, that's just 2 times 2 times 3. Or 100,
That's 2 times 2 times 5 times 5. Even some gigantic, crazy number you can think of has its own unique recipe of prime ingredients. Everything comes back to these fundamental building blocks. All right, so let's pause for a second. On one hand, we've got this math of chance, probability. And on the other, we have the math of absolute certainty, prime numbers. So why should we care? Why is it important to get a handle on both of these concepts that seem like complete opposites? Because this is the real power of math. It's like a toolkit for understanding the whole world. For example, math helps us calculate the probability of someone guessing your password, but at the same time, it uses the absolute certainty of gigantic prime numbers to create the encryption that keeps that password safe to begin with. You see? We actually need both of these ideas, chance and certainty, to make sense of the world around us.
And that leaves us with a final thought to chew on. This whole way of thinking, looking for both the random stuff and the fundamental stuff, it doesn't just apply to math. You can use this idea for almost anything. So the big question is, where in your world can you find those prime, unshakable building blocks, and where do you need to be calculating the odds? It's a really powerful way of looking at, well, just about everything.